last class, we learned how to write tests for Cairo programs. And though there were a couple of frictions, and uh, we couldn't really complete the tasks that we were supposed to complete for the last class. So we'll just build upon that for today, and we'll also round up testing as well. And for just for your information, today is the last day of uh, testing. So if you have any question or anything that finding you are finding it hard to understand, if you have any question or any parts that you're not clear with pertaining testing, you can let me know. We're happy to attend to them. So let me share my screen so we can get started. Okay, can you guys see my screen now? Please confirm if you can see my screen. There is a thumbs down. Okay. Let me reshare my screen once more. Problem with that. How about now? Can you guys see my screen now? I don't know, it's showing me some kind of warning, but can you see my screen now?
No.
Wow. What could be the problem?
Maybe you should just leave the call and rejoin.
Okay, let me leave the call and rejoin. I think that will solve the problem. So how about now? Can you guys see my screen?
Yes.
Oh, awesome. Thank you very much. So I guess we're good to go. Okay, so for the last class, we attempted using Starknet Foundry, but we had something with problems. And that was a general problem with GitHub code space. So we are going to be using GitHub code space as well today, because I think the problem that was uh, preventing it from allowing us to proceed with our last class has been fixed. I used it after that time and it worked perfectly. So we are going to continue using it. So I'll just go to github.com, GitHub code spaces. Okay, this is really important. So I create a blank code space. But before we proceed, so far, is there any question pertaining writing tests for Starknet smart contracts based on the resources shared and based on what we've done so far? Is there any question? If you have a question, you can unmute. I can't really see the chat right now because I'm seeing my screen currently. So you can unmute if you have any question or you want to speak. So I'm just going to fill the guide. I believe there is no question. Okay, I believe we are all good. So I'm just going to follow this guide to install the necessary packages. Okay, so all right. Can you confirm if you can see my screen and you can hear me? Perfect. So this is going to take some time because this is the first time I'm compiling this package, this Hello Starknet project. So this is going to take some time, and subsequent compilation wouldn't take this long. So in case you are running this locally on your machine and you encounter such a scenario where it is taking this much time, just know that it is normal and it is expected to take this much time. But before the compilation ends, let me quickly open our comp.
Hello, please, can you just zoom out your vscode a bit, please?
Okay. So I believe this should be okay. Okay, so we are going to be writing a contract, a simple contract. And using that contract to demonstrate all of the tests, all of the testing capabilities provided to us by Starknet Foundry. So the idea is that if you can write test for such a simple program, then of course you can write tests for more complex and complicated programs. So before we proceed, I'm going to be clearing this default code that came with the default boilerplate code came with installing the new package. So I'm going to be clearing this as well. So let's start by creating a file and importing that file in. Now, the first thing we're going to do is to create an interface. And over here, for this, so that is it for the interface for contact contract. And as you can see, the interface has three functions: set count, get count, and get admin. So create an implementation for this interface. Move this. So while I code, if you have any question, you can just draw my attention. The reason why I'm not explaining the code, this is not the focus. Okay, this is not the focus of today's class. The focus of today's class is testing. So I'm just going to type this code by hand, and then we'll proceed to writing tests for this contract code, right? So when we get to testing, you can ask me any questions you want, or perhaps if you don't understand any part of the code, you can draw my attention, because I believe by now we must have understood how to write basic smart contracts such as this. I think we are all good, but in case you are not really comfortable, you can always draw my attention. Glad to attend to you.
Yeah, I think sorry sir, when you are done with the code, can you just you know, copy the code and send on the chat so we can follow up.
Okay, no problem. So I'll do that also. Are you the one that raised your hand up?
Yeah, I
So,
didn't raise my hand up. I wanted to ask a question. Yeah.
okay, you are some Tojuku, right?
No, no, I'm not Santojuku. No.
Okay, okay, I can see that now. Some Tojuku, you raised your hand up.
Yeah, can you hear me? Network is really bad.
Sure, I can hear you.
Okay, go back to your code, please.
Okay.
Okay, now line 12, right? I thought you can only import contract address type from Starknet.
Okay, so this is what is happening here. I already imported the contract address over here. So it is available outside the scope of this module, this counter module. So the reason why I can import it here is because of the
Oh,
fact that it's
okay,
available
okay, I
outside
got
the
that.
scope.
Okay, I didn't see line 1 at first.
Okay. My screen is frozen. Can you confirm if it is still frozen?
I I don't think so. I don't think so because I'm saying it is moving.
Okay. And Kojo, can you please translate your question or text into English? I don't think that is in English, and I don't understand that language. So if you could please translate it to English, I would be glad to attend to you.
Um, I don't think it's a question. I think it's using an extension to transcribe. That's what the
Okay.
message.
Okay. So this is all there is to our function, the functions in our contracts. So next, the next thing we'll be doing now is writing the tests for these functions that we've created. Okay, I think we have a minor problem here. Okay, so this is supposed to be contract scripts. So I think we are good to go. Okay, so this is our test file. First thing we'll be doing is to write a function, an helper function that will deploy this contract, because we'll be deploying the contract for every function and every test function that gets executed. So in order to make it easy for us, we are just going to create a utility function that can be used in all of the functions, all of the test functions that needs to deploy the contract and use it with a clean state.
Yeah, sorry, sir. That's line 2. You imported the SM pod. Like, can you just explain that line 2?
Okay, so what line 2 is doing is importing a couple of traits and function that we'll be using in our test file. And the first function, and the only function, here is declare function. So what is declare function does is that it declares contracts by using a contract name and returns the declared contract to us. So what this other trait is doing is basically giving you access to some of the packages, some of the libraries of Starknet Foundry. So this is like giving life to your tests because without this declare result rate and contract class rate, you run your test, your Starknet Foundry won't understand the content of your test. So these two guys are like giving you now this declare results straight now. When you declare a contract, right, and you return the contract class, it is this declare results straight that makes that possible. And also contract class straight in conjunction makes this possible as well. So in summary, this line here helps to make declaring your contract from just with this few lines of code, it makes it possible. So as you can see, the deploy function takes in a byte array parameter named name. It returns a contract address. Now this contract address is the contract address of the contract that is to be deployed. So when the contract is deployed successfully, it returns the contract address. So this particular line 5 actually helps to declare the contract. And line 6 is where we created our constructor argument. And if you look at our contracts, the constructor is expecting admin address. It's expecting a parameter admin address. So we are going to be adding that shortly. And in line 7, this is where we take the contract and deploy it using the deploy function. And then we pass in the constructor argument. Whatever was here, we pass in. And we unwrap the results in order to get total, which returns the contract address for us. So over here in line 8, we are returning the contract address. Now for the constructor argument, let me just take this out. Now you can see that this is expecting an address, admin address. So what we're going to be doing is to create an account module because we will be, this is a good practice, right? When you want to simulate different user interactions in your contract, right? You will need various accounts in order to carry out that action. And in that case, you don't need to start creating these accounts individually using magic strings. I can simply just come and say admin dots. Yeah, I can simply just come and say passing this as the admin address. But the problem is whenever this code is being reviewed, maybe in the future, magic strings like this are not really, they don't really help the readability of the code. Why? Because it will be definitely very sure it will be hard for whoever is reading this code to understand what this is. Apart from the fact that it is admin, so admin what, right? The first question that will come to my mind is why are we using admin here? Why couldn't we use something else? And what is it actually doing? So in order to tackle this, we will be creating creating an account module. So this will manage all of the accounts in our contract. Now our tests. So first of all, imports contract address and it imports trying to create. The first account will be creating is the admin account. So let's simply say admin try into dot. So this is the admin account. We'll be using this admin account in constructor argument. So the first thing we'll be doing is to test if the deployment was successful. We'll create a test function for that. Public tests. So let's deploy the controls. Okay, let's call this. Now, this when you want to call the deploy function and passing the name to match with the name of our contract. As you can see, this is our contract. This is what denotes this annotation is what denotes the starting point of the contract. So as you can see, the name of our contract is counter. So passing the counter. So the next thing to do is to get an instance of this contract. And in order to get instance of deployed contract, we use what we call dispatchers. So let me explain something about dispatchers. But before I explain dispatcher, let me explain contract interface. Now, contract interfaces define the structure and behavior of a contract. And of course, you can see that in our counter contract, these are functions, right? And they represent the structure and behavior of our counter contract. So if you are looking at this interface without even looking at the implementation, without looking at the contract, you can easily tell that this contract sets a count value, get count value, and get admin address. So automatically, by looking at the interface, you already know that this counter contract actually perform these functions, these functionalities. So that is one. And secondly, the server as a contract, public ADI, application binary interface. So if your contract needs to interact with other contracts, that can only be done using the contract interface. If your contract doesn't have an interface, then it can't communicate with other contracts. It's like how the graphical user interface is, right? It interfaces the computer with the human, the user. That is how this contract, interfaces your contract with other contracts. So each time a contract interface is defined, two dispatchers are automatically created and exported by the compiler. Now, when you look at our code, we created an interface. So what this means is automatically the compiler creates and exports two other dispatchers for me. and one of the dispatcher is simply a dispatcher, while the second one is a library dispatcher. So in our case where the contract is counter, this will now be counter to okay, I don't want to edit that, but this will now be counter dispatcher. So counter dispatcher like this. Then the second one will be so when this interface is created, the compiler automatically creates counter dispatcher and counter library dispatcher based on the interface. Now, in addition, the compiler also generates a dispatcher trait. Don Chris, can you ask your question?
All right, all right. Can you hear me?
Sure, I can hear you.
Okay, like that's the spatial you're talking about. Does it apply like whenever maybe you can contract, like the compiler will automatically get the spatial for you based on the contract you are trying to create? Is that what you're trying to say?
Dispatchers are created when you create interface, not contract. Because an interface is
Yeah.
from a contract. So is that your question?
Yes, exactly.
So I believe it has been answered.
Yeah, sure. Thank you.
Okay. So there's a difference between contract dispatchers and library dispatchers. So contract dispatchers are used to call functions from another contract, while library dispatchers are stateless. And if you've written Solidity before, you must have come across the concept called delicate call. So that is what library dispatchers are similar to. They don't interact with states. This dispatcher and dispatcher traits that was created by the compiler from the interface will be what we'll be using to interact with our deployed contract. So we have a contract address. Next thing to do is to import the dispatcher. So let's do a full import. That's the name of the import. Hello, Starknet. So let's get an instance of the deployed contracts. So after getting the contract, we check the admin address to verify that it is what we first name here as the owner that is actually there. So we say okay, so let me so we want to compare this part. Let's get the admin address. This return the contact address. So this is it for our test. What we are planning to achieve in this test is to verify that the deployment was successful. So as you can see over here, we deploy the contract and we got the contract address. Over here, we got an instance of the contract. Over here, we are calling a function from the contract name get admin in order to get the contract address of the admin. So this is the admin address, and we're comparing the admin address gotten from the contract with what we deployed the contract with. So, Starknet. So we have a couple of typos. Let's see where this typos are. Identify not found. So this is expected to be okay, line 17. This is expected to be account. So in line 39. Line 39. This is not found. So did I make any mistake in the imports? So I'm not supposed to put this. Okay, I think we have one last error. So the error is coming from the constructor. Let me see. Okay. With the problem. So this is what I want to point out. Now in Cairo, when writing a static smart contract, the constructor arguments are expected to be in felt for 252. So the route type you have, you want to use it in the constructor, it has to be felt 252. So what we do, can do here is to convert this into a felt 252. As you can see, the first test now content is passing, which means everything is good, going fine. So after testing the deployment, the next thing to do is to test the set function. Now, when you want to test, right, you test for assertions in a function like this. Right, like in line 36, there's an assertion that says column must be admin before this function can proceed, and there's another assertion that says volume must be greater than 0. So first tackle, or for a start, we'll tackle this assertion in 36. So expect evidently responding. Expect set count to point. So we'll name the function tests. You should pan it. So our function is basically checking to verify that set count to pan it can call for an unauthorized address. So now in order to achieve this, we add another address. This is another account one. And the reason why we are creating this account is because we are going to be using it to call the set count function to verify that this assertion is working as expected. So the first thing to do is to declare this function. Okay, so the name of our contract is counter. After deploying it to so this is I was getting an instance, so I'm gonna do it. So I believe there's a question. Can you go ahead with your question?
Okay. First question, is it authorized or unauthorized?
Sorry, I didn't get you. Can you come again? Can you ask that question
I
once
don't need
more?
to get you.
Can you ask the question once more? Didn't get you.
Yeah,
Can
I'm
you ask
asking
the question
the
once
first
more? I didn't get.
question when unauthorized.
To be honest, I'm not hearing you.
Or
The call is breaking.
Okay. Can you hear me now?
Yeah,
Can you hear me?
sure, I can hear you now.
Should panic when
Yeah, I can hear you. Go
unauthorized
ahead.
or authorized?
Okay, so look at it. When you call this function with another address that is not the admin address, then it means you are not authorized to call the function with that address. You can only call this function with the admin address. So what we are checking is see that you cannot call this function with any other address apart from the admin address. So did that answer your question?
I understand what you're saying. I'm like your this thing. It should be unauthorized, but in your function, you wrote authorized address. Should panic from authorized address.
Okay, thank you for that. Thank you for that, for noticing that. So before we proceed, let me explain the concept of panic to you. Okay, sorry, not panic. This, I believe it should be okay. So what I want to explain is the concept of cheat code. So Starknet Foundry provides what they call cheat code. Now this cheat code is it contains some set of functions, and these functions allow you to simulate some parts of a contract. So basically, cheat code allows you to have more control over your contract, over the contract you are testing. For instance, if you have a function that uses get call address, of course you know that if you are calling that function from a web browser, from a DApp, where where your wallet is connected to, the get caller address that is used in that function will be your address. Let's say agent, for instance, will be the address of the account you created on agent. But you know, when we are testing, you cannot simply do that because all we are doing here is writing codes. There is no front-end integration that will enable us test functions that we just added in in our contract. So that is where cheat code comes in. Cheat code allows you to, for instance, let me give you an example. There is the start, there is the cheat code that allows you to plan, that allows you to simulate caller address. So let me just quickly open it. Um, so the reason why I'm explaining this is because we need to use a cheat code in order to call this contract as the admin. Because when we call this contract with an unauthorized address, it's going to panic. This is cheat code. So these are all the cheat codes available to be used in Starknet Foundry. Now, this particular cheat code, once you understand how it works, then you should be able to understand how cheat code works again. So this cheat caller address, for instance, now what it means is when you call a function in your contract, it will use whatever address you specified over here, call to make that function call. So let's go back to contract. Now we want to use this cheat caller address. So we use this one that says start cheat caller address, and passing does the target contract on the caller address. So let's say so passing the contract address. So if you want to make an unauthorized call, simply use the count one. So this line here basically allows me to call any function in my function as the caller address. So this address is what we will use as the caller address. So after adding the cheats, the next thing to do is to make the function call. So then enter this password. So person 99. Now, one last thing I want us to note is that if you have a function like this, a function that if you want to make a function call, you are expecting it to panic. Like in our case, we are pointing the caller address as a custom address of our choice. And in the next line, we are calling the set count function. So in this case, it is obvious that set count function will throw an error or it will panic. So when you're expecting a particular function call to panic, what you can do is to add panic. Now we're expecting it to panic with caller not outgoing. We're expecting it to panic with caller not admin. So this is it. Now one other thing I want to show you is when you want to fill that test, you can simply add that test name. Let's see. So let me simply paste in this test name. So what this means is I want to run only this test. So I'm supposed to write in all of the tests. I'm supposed to run in all of the tests in your code base. You might have 100, 200 tests. So you don't want to run all of those tests just to verify that the last or the one last function you added to your test works as expected. So we have this minor error. So function of found 938. Let us see. Okay, test counter local. So which function I would call it that Scarb is continuing, right? Okay, this test was actually awesome. What do we do now? function of fun. So it should be probably misspelling or that minor problem. So let's see. Set count and dispatcher. Is expecting a value. Okay, so let's see why it's not building. Let me run this once more. Okay, it is still showing that error. So I think the first one was passing initially because the line of code I was highlighted didn't match with what I have currently. So as you can see, this initial test passed. So definitely the problem must be here. So deploy counter. Double counter dispatcher. And passing the contract address. Oh, this is the problem. Start sheet caller address was not imported. So in order to import it, you simply add it over here. Okay, this is let's see. Oh no, I copied the wrong. I'm supposed to copy and paste this. The wrong stuff. Okay, still isn't let me just making a start sheet for address. Okay. Okay.
Uh, are we sure it's not from the should not panic?
No, it's not. So it should compile now. Here is where the problem was. This account. I was using an account that doesn't exist. So as you can see, to tell the best of person, I think this function is what was expected, but let me take out this line and we'll see that this function, or instead of this quality, let me put let me negate that. So if I run the test now, it's going to fail because the contract is not working as expected. So as you can see, it failed because I changed the logic directly from the contract. So we just used cheat code and expecting a contract to run it. So another thing I want to show us is save dispatchers. So if you want to, now this is a dispatcher, right? And when something happens, Starknet Foundry automatically handles it for us. But if you want to undo, funny that to happen in your function call, that's when you can use save dispatchers. So write a test that utilizes save dispatcher now. We should find a code with the same value. This it is basically the same here. I'm just going to copy that and paste it here. So in this case, we want to use the actual owner. If we want it to pass, we want this test to pass. So we'll do the right thing at this time. After fitting, you want to call set count. So this is a call to the set count function. But instead of 99, let's use 0, which is not what we are supposed to use there. So in order to use save dispatchers, we have to import it. So instead of dispatcher, we just use save dispatcher. We'll modify this to so now calling this function will return a result. So now we want to check the result variant. If it is an okay variant, use an OK variant to make the data. Now we're gonna panic here.
Yeah, I think he didn't put the close the parentheses at that line 63. Yeah.
Okay, yeah. So let me quickly explain this. 62 5. So using a same dispatcher, when you make a function, when you back to the function, it returns the result in, and the result in has two variants, the OK and the error variant. So if this is OK, if this is OK variant that gets returned, it means there's a problem because we are expecting this to find it, but it's returning OK. So for that reason, we are going to panic. So we're going to panic and say should have panic because we're expecting it to panic and it didn't panic. So secondly, if it panics, which means it's an error variant, you're taking the panic data, a snapshot of the panic data, and get the, because it's in an array, so we get the first value and we verify that it's equal to this. If not, we throw error. So, of course, because we're expecting this function to panic, we test. Okay, so this is for your information. This is a very common workflow, so it is usually difficult to get your function code right on the first go. Let's look at the error, not the variant. Use the full name.
Hi.
Yeah, you have a question?
I think there's a spelling issue on line 62. There's a missing underscore. Line 62. Panic data.
Yeah, it's supposed to be. So let's run the test. Okay, so just one sugar this time. Okay, this is weird. Weird. Hopefully, we'll figure this out. First of all, let me format
Then on that line 61, like that okay results okay, the underscore in that parenthesis, are you the one that's put it there or just like?
So the underscore there is like saying is a way of silencing unused variables in Cairo. So because this will return the data, which I don't know the content of it for now, but I'm not going to be using that data. I don't care what it is. I don't know. I'm not going to be using it. So in order to avoid warnings from the compiler and undo unused variables, that is why the concept of underscore exists in Cairo. So we'll quickly scan through this. Going to save this project. So we match counter save this project. Return error 0. So from this snapshot, the comment data, we just need point data and then we compare the snapshot to whatever we have here. So let's do that. Okay, Scarb commands and actually the code. Probably yeah, I still facing some errors. I think it's not visible in this context. Okay, this is where the error is coming from. Let's see. Result okay. Okay. Cool. There's one. It's just one good for 252. Function not found. 49. This is giving us the it's not reporting properly. So we say function not found. Function not found. So which of the functions is having a problem with? Okay, this is finding data. Oh, this is supposed to be the new. Okay, perfect. So as you can see, all of our tests the person. We went through a brief debugging session, but finally, they are now passing and verify that this code works as expected. So at this point, do you have any questions? Do you have any parts where you are probably confused or wanted to clarify? Thank
Yeah, yeah, please, can you go over this last test? Let me understand the logic.
So this last test is basically testing that set ownership panel point called with 0 address. But if you look at it, we are not using should panic. The reason is because we want to do it ourselves. And this is made possible by same dispatcher. We'll get an instance of this contract using the same dispatcher. After that, we start cheating. We are calling this touched caller address. We like to call the set and contact address with another. We like to call the set count function again with a different caller address other than the owner. So over here we are checking for the result. If it is okay, then we panic because we are expecting this to panic, but we didn't. So another thing is we check for the error, which is what we are expecting. And if the error equals, if the error that occurred equals the message showing the error contains the message that we are expecting, then this test pass. Else it returns whatever is blocking, whatever is preventing us, whatever is preventing us from. So whatever is preventing this check to pass. Okay? So if panic data at 0 is not equal to this, it returns otherwise there. So that is it for the question, for the question, for the function.
Yeah, I'm sorry, sir. The why is there asterisk and the panic data? Why is there asterisk before the panic data? Like, what's the function of the asterisk?
Okay, thank you for that question. That is called a snap operator. So if this snap operator, right, is is to convert a snapshot back to a regular variable. It's like a snapshot operator. Of course, you know a snapshot operator allows you to get a snapshot of that particular variable. Right? But the snap is like the opposite, right? Converts a snapshot back to regular variable. So one thing about this kind of operator it doesn't with this operator is whatever variable is attached to, it doesn't take ownership. So over here it says it enables the review your use of code while without taking ownership or modifying the original variable. So do you understand what that STRK means now?
Yeah, sure I do.
Okay. So is there any question? We covered quite a lot today. So I'm expecting a lot of questions. You? Oh. And one last thing, just know that I will be giving an assignment for the 3 sessions that we had together. So once the assignment is ready, it will be sent over to each and every one of us on this call. So it will be sent through the communication platform used to communicate to everyone. So is there any question to come to the end of this class? Is there any question? Is there anything you want me to clarify?
No, so thank you so far. Then about the code, like how will we get it? Maybe the GitHub link.
So I'm going to be pushing the code to GitHub. I'm going to be sharing this immediately, this note. So for the code, I'm going to be pushing it to GitHub. So once I've pushed it to GitHub, you can access it from there. The link to the code from GitHub will be shared to you. Did I answer your question?
Yeah, thank you.
Okay, well, so is there any question? I'm just going to wait briefly to see if anyone else has a question. So I end the call, but if you have a question, you can draw my attention. Before then, you can go through the code. You have to build up a question. So you have to build up question that you can ask. You can go through the contract, you can go through the test. Anything you don't understand, you can draw my attention.
No one is talking again.
Yeah, I opened up the floor down for anyone to ask questions. So in the next couple of minutes, let's say 2 minutes, we'll be ending the call. But before then, if any question comes to your head, you can definitely ask.
Okay, and then sorry again, off topic. Like, what's your maybe any of your social handle? So maybe if we get problem or you can help us solve at least. Maybe if not, if maybe depending if you don't want to give us any of your social media we can contact you with.
This is my Twitter. So you can contact me via Twitter. Drop a message.
Okay, just send the user. Okay, just send the username on the chat. Yeah.
You can also reach out to me on Telegram. Inside years on Telegram. So I believe we are all good. So this will come to the end of this session. And thank you everyone for following. And thank you for being there for the past couple of classes. So this marks the end of testing. Testing Starknet contract with me. I believe next week you do something different. So if you have any question or any challenge related to testing during the process of developing a smart contract, you can always reach out to me with provided social media platforms. I would be super happy to attend to you. So we can call it a day.
Yeah, thank you so much, sir.
Thank you. Thank you for attending and have a good night.